Hello everybody, welcome to Transy Learning Mathematics video. Today we are going to discuss about real numbers, and in that we are going to prove why root 2 is an irrational number. In this video I've explained in detail that what are integers we are going to take and why we are taking co-prime integers, and then we are proving our assumption wrong. In that case, I will explain you in detail that how we are going to assume, first of all, that root 2 is rational, and then we are going to prove that root 2 is irrational. We are going to prove our assumption wrong. So let's start. So we have to prove that root 2 is irrational. So now we are going to start the steps. The first step is we are going to do some assumption. Assume that root 2 is rational. So we can find the integers r and s such that root 2 is equal to r divided by s, right? Now we have to suppose that r and s has common factor other than 1. What does it mean? That suppose r and s has common factor other than 1. So in that case, we can divide it by the common factor. So we are assuming here that r and s has a common factor other than 1. Then we can divide it by the common factor to get root 2 equals to a upon b, where b is not equals to 0. And here, where we can consider that a and b are integers and b is not equals to 0, and a and b are co-prime. Now what do you mean by this co-prime? So I'll just explain you this co-prime. What do you mean by this co-prime? Co-prime are those numbers that do not have any other common factor other than 1. Let us understand the concept in this case. We have assumed here that the root 2 is rational, and we are considering that let root 2 is equal to r upon s, and r and s has common factor other than 1. Then we can divide it by the common factor to get root 2 is equal to a upon b, where b is not equals to 0. And here a and b are integers. So what do you mean by this? If I explain you, I have considered in the first case that root 2 is equal to r upon s, and I have considered that r and s have some common factor. Now when we are going to cut this with the common factor, we are going to get a divided by b, where a and b are co-prime. That means they do not have any other common factor other than 1. For example, if I tell you, if I take root 2 is equal to say 4 upon 6. Now in this case, 4 will be your r and 6 will be your s. They have common factor 2. So now if I divide 4 by 2, I will get 2. If I divide 6 by 2, I will get 3. Now this 2 is your a and this 3 is your b. Now a and b are co-prime because they don't have any other common factor. This r and s has the common factor as 2. So that is why we have taken the 4 variables. We have first of all taken r and s. R and S have some common factor other than 1. Now when we are cancelling down, or when we are taking that common factor, we will get the values of A and B. This A and B will be co-prime. It has to be co-prime. That means they will have no other common factor other than 1. Like if I consider the factors of 2 into 1, if I consider the factors of 3 into 1, the 1 is only the common factor. They have no other common factor other than 1. Let me give you another hypothetical example. So another hypothetical example, let me take root 2 is equal to say 5 upon 10. 5 is your r and 10 is your s. Now here the common factor is 5. If I take the common factor 5 on the 5 and you have the 5 to the 10. Now this one will be your a and this will be your b. So if I check the factors of 1, this can be 1 into 1. If I check the factors of 2, that is 2 into 1. So they have no other factor common other than 1. So 1 and 2 in this case are co-prime. And in this case, 2 and 3, they are co-prime. We are going to proceed with A and B. Now I am going to proceed further with the A and B. You can consider that root 2 is equals to a upon b. What I'm going to do here, I am going to take b on the other side. So I will get b equals to a. Right. Now I am squaring both sides. So I will get b root 2 whole square equals to a square. So I will get this 2b square equals to a square, or I can get b square is equal to a square divided by 2. So now we have to consider the theorem what we have talked about earlier. Let p be the prime number if p divides a square, then p divides a, where a is a positive number. Now we are going to use this theorem. So now we got b square is equal to a square by 2. We can write if 2 divides a square, then 2 will divide a. If 2 can divide a square, so the 2 can divide a. This means that one of the factor of a is 2. Got it? If 2 divides a square, then 2 divides a. This means that one of the factor of a is 2. We have proved this, that a is a number which has 2 as one of the factor. Now let us see about the b, whether b has 2 as a factor or not. Now we are going to consider let a, what you have proved, the one variable which you have taken here, that you are going to always assume as with the third variable. We had b root 2 is equals to a. So we can write b root 2 is equal to 2c. Now again we are going to square both sides. So this will be b root 2 whole and c whole square. So what we are going to get? We are going to get 2b square is equal to 4. So in this case, squaring b root 2 whole square is equal to 2c whole square. I will get 2b square is equal to 4c square. Let me explain you further. Now I will get c square equals to 2b square upon 4, or I will get c square is equal to b square upon 2. This is as per the theorem. This is c square is equal to b square divided by 2. The theorem that we did, we can consider here that if 2 divides b square, then 2 divides b, right? So that means b has one of the 2. So now we can conclude that a and b both have at least 2 as a factor. But this contradicts the fact that a and b are co-prime. Means they have any other factor other than 1, right? So we can conclude that this contradiction has arisen because of our incorrect assumption that root 2 is irrational. Therefore, root 2 is irrational number. So root 2 is the irrational number. So now what we have done, I'll explain you first. First of all, we have taken R and S. This R and S are not co-prime. They have some other factor. After we remove the common factor, we have taken equal to A and B. Now you can very well imagine this is a very important step, because we have proved here we have taken A and B such that A and B are co-prime. That means they won't have any other factor other than 1. And this we are going to contradict it ourselves. So we have taken root 2 is equal to A upon B. B root 2 is equal to A. We are squaring both sides. So B square is equal to A square upon 2. Now as per the theorem, if P is a prime number, if P divides A square, then P will divide A. Now we have proved that B square is equals to A square upon 2. That means if 2 divides A square, then 2 will divide A. So this means that one of the factor of A is 2. We have proved that one of the factor of A is 2. We have to prove whether B has a factor 2 and not. So we are going to consider A as some other integer, that is 2c. We are going to substitute the value of A as b root 2 is equal to 2c. We are again going to square both sides, and we are going to get the value of c square is equal to b square upon 2. Primarily we should see that what is dividing b square. So we can see here that b square is getting divided by 2. So that means b will also get divided by 2. So that means b has one of the factor as 2. A and B both have at least 2 as a factor, but this contradicts the fact that A and B are co-prime. We already proved earlier that A and B are co-prime. They don't have any other factor other than 1. But now, after solving this, we got the factor which is common in A and B is 2. This contradicts our statement. So this contradiction has arisen because of our incorrect assumption that root 2 is rational number. So that means the root 2 is irrational number. Remember, don't do any cut short because every step is very important in this case. Thank you very much for watching this video. For more videos on proving that root 3, root 5, root 7 and root 11 are irrational, and then we are going to prove 5 minus root 3 is also an irrational number, and many more, please visit our YouTube channel Trans E Learning. Thank you very much. Have a great day.